In this video, I am going to discuss the calculations for the emission spectra lab. Let me first discuss the setup. So this is the setup that you see in the pictures, where this is the diffraction grating, where we see the light through. This is the light source, whether it's the hydrogen or the mercury lamp, but this is the light source. And these are the meter sticks. Now, X is given to you as the length of the meter stick, which is 100 centimeter, and that won't change. The only thing that you're going to measure and figure out is going to be the distance from the light to those lines, the spectral lines of hydrogen and mercury, so the distance Y. Now, note that this doesn't start at 0, it starts at 50. So you're not going to measure from 0 all the way here, but from 50 to wherever those lines end up being. For that, you're going to look at the pictures and zoom in and do your best to estimate the distance. It's not the easiest thing to do, but you'll do okay. You're not being graded on how accurately you report, but how you do the calculations. And I'm going to kind of give you a hint that those values should be somewhere between 20 and 40 centimeters. Just kind of a way to check yourself to see if you've done it right. And once you have the Y and the X values, then you can calculate the Z, which is this hypotenuse of a perpendicular, or at the triangle, right? Right here we have, this is a 90-degree angle, and so we can use the Pythagorean theorem to actually figure out Z. Now note this is Z squared is equal to X squared plus Y squared, not Z equals X plus Y. You know the X and the Y values, so plug those in, square them, find their sum, and then take the square root to figure out Z. Here's what it looks like through the diffraction grating. Here's the hydrogen lines, the lamp, and here's the spectrum. So you're going to zoom in on this picture and go from 50 to this first line right here and measure the distance. And then the second line right here, and then the third line right here. Do your best, like I said, and estimate. You are not being graded on how close you come and how accurate these readings are, because they are not the easiest thing. And then here's the mercury line. The same thing. You're going to zoom in on this picture and measure from 50 all the way to this line right here, and this and this. Okay, so these three lines. Once you have the Z value, you're going to find the sine theta. Now don't let this get you all scared, because it's a trick. We're not going to do anything with the sine theta itself to get the theta, the angle, to do trigonometry there. But all we need is to find what the sine theta value is. And to do that, we're going to do the Y divided by the Z. So Y value that you estimated divided by the Z value that you figured out. This is going to give you the sine theta. Once you have the sine theta, you will need this little piece of information as well that you get from the pictures. The wavelength in centimeters is given as 1 centimeters or over the lines in grading, which is given right here, 5360 lines in the grading for every centimeter, multiplied by the sine theta value that you just figured out in the previous slide. So you will plug in the sine theta value from Y over Z that you calculated it, and then divide that by the lines in grading that you get from this picture. You then will have the wavelength in the centimeter range. The last thing that you need to do is calculate the wavelength, or convert it from centimeters to nanometers. 1 centimeter has 10 to the 7th nanometers. So you're going to get the value that you get from this calculation multiplied by 1 times 10 to the 7th to convert to nanometers. those values should be in the hundreds of nanometers. If they're not, then either you have not quite been very accurate in estimating the Y value, or you've made an error in your calculations. If you haven't made an error in the calculations, then your estimation might be off, and that's okay. Lastly, you are going to calculate the percent error. The percent error is an absolute value, so never report percent error as negative. These are always positive values. But in your table, you have this ACC lambda in nanometer or ACC wavelength in nanometers. That stands for accepted value or literature value. These are values that you can find from the internet. Do a simple search on the spectral line of hydrogen and spectral line values for mercury in nanometers, and you will get those values. Match them as closely as you can with your experimental values that you calculated, and then you will do this percent error calculation. So you will take the values that you looked up from the internet minus the value that you calculated in your work divided by the accepted value. Now make sure that when you do these, you do the difference first, hit enter, and then divide by the accepted value again. Then don't forget to multiply by 100 to convert it to a percent. Now you may have a big percent error, or it may be small, depending on how well your estimation is. But once again, you're not being graded on how close you come or how small your percent error is, but whether you have done the calculations correctly.